This is an Atwater Kent model 165. The on-off volume is over here. And we've got the tone here. And this is the tuning. And I want to show you this right over here. Notice that part of it's missing. Evidently somebody tried to clean this and they used water, and what you have to be aware of, a lot of these dials are water soluble. So I don't know if we're going to repair this or not. There can be a lot of things that might cost quite a bit of money to repair this type of radio. This radio's got 2.5 volt tubes, and it's got an 80 rectifier, which is a 5 volt tube. But the 2.5 volt tubes are, well, they're not unusual for this type of radio, but the problem is if that transformer is bad, the power transformer, it can be a real problem finding a transformer for this type of radio. Okay, now I've turned it around, and it's got 1, 2, 3, 4, 5 tubes in it. And another problem could be the speaker. It has a field coil. So repairing one of these radios can be pretty challenging as far as money goes. The electronics is like any 5-tube set, pretty much. This was in 1933 is when this was manufactured, and RCA licensed super heterodyne in 1932. So this is a super heterodyne set, and I think it's only got one IF, and this might be it here, I'm not sure. We'll have to take this out of the chassis to find out. But yeah, these 2.5 volt tubes can be a problem. This is the 80 here, and this is a 2A5. This 2A5 is the audio output, and I think it draws like a couple of amps on the filament. And some of these others draw an amp, and this one's not even hooked up. Well, it fell off. And, well, we're just going to have to take it out of the box and see what we got. This is the underside of the chassis of this Atwater Kent. And you can clearly see that somebody has been in here and done a repair to it, which may be good or bad. And I'm thinking this may be okay, because if you look in the center, they have done this right. There's two round objects. Those are the filter caps, and they have been disconnected completely, which you always want to do in these old radios, because these can short out and cause real big problems, like burning out the power transformer. The meter that's on the right, it's reading about 2040 ohms. I've got that connected to the field coil, and that's to 2 big pins, and that seems about right. A little later, got a little video on how to check out the audio transformer and the voice coil. Here's the wiring diagram for this radio. Now what I'm going to do is I'm going to check out the field coil, which is lower center right a little bit. You see some dotted lines going up to the field coil. That means that it plugs in. You can see the 3 pins. Now check out the field coil. It's reading about 2,000 ohms. And then the primary of the audio transformer. And one of the harder things to determine is, does the speaker work? Even though the audio transformer reads about 500 ohms, which it does. So we'll show you how to do that using a 9-volt battery. But that's just the beginning, because I'm going to be checking all the coils, including the power transformer at the lower left, and all the other coils that you see in this wiring diagram. And of course, I'll be checking all the tubes. And if all that checks out, I'll put this radio on the variac and bring it up very slowly to see if we get B+ to all the tubes, and maybe we'll get lucky and hear something. But this will be a while. This is going to take some time to check out all these coils. I tested the ohms of this, and there's nothing open, and it looks correct. Like there's a couple of thousand between here and 500 between here and here, I think it was. So let's see if the voice coil is okay. We're just using a regular 9-volt battery, and I do hear a little something there. I don't know if you can. Let's try this side. Oh yeah, that's louder. Okay, so that should mean that the field coil is good, the transformer is good, and also the voice coil. Well, that's very good news. Thanks for watching.